Hey folks, alright, I just wanted to do a quick rundown of lab exercise 2 for folks who couldn't make the lab this time around. I don't think there's going to be anything too horribly shocking in here. Again, so if you check out the project page, as with all of the different labs, there will be some changes made to the project specs. So I've been trying to put a little blurb down at the bottom that just details what's actually changed this time around. So all that's happened this time is we've added specs for that file name that's going to be included. So when the user invokes the program, they're going to run the program and provide the file name for the building and elevator data as a command line argument. And the only other change was in the sample output from the program. I had forgotten to include the up-downs for which direction the elevator is traveling. So that's been added. Those are the only changes to the project description for this particular lab. More significant changes will come up in future labs. For the lab itself, as always, you're going to do the git pull. You can ignore this. The repo has been updated, so it is safe to pull it now. Again, I'm assuming that you're keeping up to date with all the lectures in the labs because I'm going to kind of rely on that as we go through it. Always check out the project description to see what changes have been made. And for this one, again, as with all of the labs, you'll either do the fetch and merge whichever, or the git pull, whichever approach you prefer. For this particular one, I don't imagine there will be any conflicts created when you pull the changes that I've made. So go into your project repository, do a git pull instructor master. This does assume that in lab 1 you actually got your remote for instructor set up correctly. But when you do this, it will go off and pull two new scripts that I've added, w.r.t and report.sh, so two bash scripts. If this fails, then go back to your lab exercise 1 and at the end of step 2, we went through the steps to add the remote for instructor. So go back to those and set up the instructor remote, and then you should be able to go through and pull the changes. So again, this has introduced two new scripts that we'll talk about as part of the specs. The preliminary design document is something that I want you to incorporate as part of Lab 2. So this can just be a plain text document. You're going to create a subdirectory named docs in your project repository, and a whole bunch of documentation is going to wind up going in there over the course of things. So for now, we'll just create a text file, design.txt. And in that, I just want you to give a preliminary description of the design you envision following to implement this program. So no worries about code or anything along those lines yet. I just want a discussion of a couple of paragraphs on the solution you envision using. So how are you going to break this down into components? You know, what classes are you going to use if you're going to use classes? And not worrying about the methods and things, just a kind of high-level description of what the tasks, what the classes are likely to be, what kind of data is likely to go in them, and what kind of services they're likely to provide. Just a high-level view. Couple of sentences of description for each of the different classes you think you're going to wind up using. If you envision breaking this program down into multiple different kind of modules or files, maybe what you see the decomposition as looking like at this point, the core routines that you're going to wind up needing. Again, don't go into all sorts of gory details of fine level, for this function is going to need these and these and these and these and these. Just a high level decomposition of the major steps you see taking place and how you plan on tackling it. And you're going to go through and refine this over and over as the semester goes on. I'm then going to get you to produce two different bash scripts. So one of them should be pretty straightforward. It's just doing grabbing a bit of Git's information about the current state of the project. So this report.sh, make it executable. So do your chmod, user plus execute report.sh. Make sure you add the hash bang in the script, because I think it's pretty much just empty at the moment. The hash bang, bin bash or whichever directory it is we're working with. And what this is going to do is run git status and direct the output into a file named current state. So it's just going to, if the file doesn't exist, it'll create it. If it does exist, it'll overwrite it. And then it'll run this git log command to get that little ASCII graph of what the project state looks like with branches and that sort of thing. So the git log, you know, dash dash graph, dash dash branches, dash dash pretty. And again, direct the output to a file called current graph. Make sure that it then does a git add on both of those, a git add on current state, a git add on current graph, and it does a git commit with your -m and using this as the message. So these are all things that are being done by the script, and the script does a git push origin all. So essentially, when you run report.sh, it's going to update current state, it's going to update current graph, and it's going to do an add and a commit and a push to send that stuff back. So that's for the first script. The second script, and I'm going to talk about this in just a different order this time around. The second script is going to take a file that's got the building description in it for a test run. It's going to take a file that's got the sample user input for a test run, and it's going to have a file for the output we would expect the program to produce if it worked correctly. And so the script is essentially going to check that the files actually, that the first two files actually exist, or the files actually exist, the three files actually exist, and are readable, writable, whatever it needs to be. And it's going to go through and run the program, passing it the name of the building file, taking its standard input from the input file, and then it's just going to dump whatever program output exists to standard output. So something along these lines, where it's running the program, you know, using whatever the name of the building file was, taking its input from whatever the name of the input file was. And so this is, other than the error checking, this is pretty much all the script is doing for now. Ultimately, we'll also get the script to capture the output from this, this command. So capture whatever the program actually produces and compare that to what the expected output file says it should have been. And if they're identical, it says, oh, it passed that case. And if it's different, it says it failed that case. But we won't get there yet. For now, we just want it to check that the three files exist and have appropriate permissions and run the program and just let the output dump to the screen. So this is the idea for the u.r.t script you're going to be writing. And you're going to be using that, well, I'll be testing that script on a bunch of cases that you create. So I want you to come up with 5 different test cases from the point of view of if the project was actually finished. So if the /project executable actually did everything it was exactly the way it was supposed to do, then I want to have ways of testing to see if it actually works. So I'm going to come up with 5 different test cases that I can use to see if this thing seems like it's correctly functional. So for each of those test cases, I'm going to need to know what the building and elevator file content would be. I'm going to need to know what the user would type in for that test case, exactly, character by character, what the user would type in, and then exactly, character by character, what output should the program produce if it's correct. So for each test case that you come up with, each of these 5 test cases, you're going to come up with 3 files. One that's got the building data in it that the program's supposed to read, one that's got the input data that the user would ordinarily type in, and again, character by character, exactly what the user would type, and then one file that's got the exact output we would expect the program to produce. So the way I'm going to ask you to organize this is to have in your project a test directory, and inside that test directory have 5 more directories, one for each of your 5 different test cases. So in the subdirectory for test case 1, you'd have the 3 files for test case 1. In the subdirectory for test case 2, you'd have the 3 files for test case 2. And then in your test directory, also throw in a little README that just describes the 5 different test cases and what you want them to accomplish. Right? The first test case, what is it trying to test? the second test case, what is it trying to test? And so you're thinking about things like, well, what are the kinds of things I want to be able to test? I want to check if it works, maybe just have one kind of general easy case where, you have 3 or 4 different stops that the elevator makes, and all the passengers fit in and everything works out fine. So just a kind of sample standard normal run, if you like. Maybe have one test case where it goes through and says, okay, well, what if there's too many passengers on one of the floors and they can't all get in the elevator? So if one of the requests has more people than the elevator can hold. So in that case, the elevator is supposed to kind of take on as many people as it can and then go off and kind of continue its run, drop people off, and come back eventually and get the people that were left behind. Right, so you want a test case to see if that works correctly. Maybe have a test case for, it picks up a whole bunch of people on one run up, or a test case where it drops off a whole bunch of people on one run down, or a test case where there's big gaps in between the user requests. So, the elevator is supposed to return to the ground floor when it's got nothing to do. So have a test case to see if that actually happens, to see if that actually works in your simulation. Right? So different thoughts along those lines. Test cases to see if the error handling behavior is correct. What if the user runs it with the wrong command line arguments, with invalid files? What if the input data in the input file is incorrect? It's missing fields, it's got extra fields, it's got text where numbers should be. What if the file holding the building data is incorrect, if entries on that are invalid? So again, think about different error handling cases. There are a lot of different cases to get started with. I'm just asking you to come up with 5, but eventually I'm going to have you expand this and expand this and expand this, so that by the end of the term we've got quite a lengthy suite of user acceptance tests, and we're going to develop these scripts to go through and automatically apply all of those different test cases and check to see if the program passes them all, so that by the end of the term we can just kind of run a testing program and it'll run all these test cases and tell me if the program passed all of them or which ones it failed. So ultimately that's the goal, but we're starting small. So that's pretty much the plan for Lab 2. And we'll see how we go.